Welcome to another unit of the ISM Exercise Set Statistics 2, this time with a unit on normal distributions. Let's have a look at the exercise. A mall contains a food court. The average customer spends 15 euros there, and in the context of a survey it has additionally been concluded that the variance of the spendings is 16 euros squared, and that the spendings are normally distributed. Then we have three tasks. The mall marketing is particularly interested in those customers that spend more than 25 euros. So what is the probability that a customer will spend more than 25 euros? Second, under the assumption that on average 10,000 customers visit the food court every week, how many persons will spend more than 25 euros? Finally, how many customers will spend between 10 and 20 euros during their visit? So let's start with the first one. Here we want to know the probability that someone spends more than 25 euros. So that's basically the same as the counter probability of 100% and that he spends less than 25 euros. For this, because we're using the distribution function of the standard normal distribution, we also need the mean and the standard deviation of this distribution. The mean is given as 15 euros, and then we have the variance. So to get the standard deviation, we take the square root of the variance, giving us a standard deviation of 4. So with these two values, the mean and the standard deviation, we can then standardize our value here of 25, because we can only use the standard normal distribution, because only for this we have a table where we can look the corresponding probabilities up. Okay, so to standardize this, we subtract the mean and the result is divided by the standard deviation. So here this means we calculate 1 minus, then phi means look the corresponding value up in the table of the standard normal distribution. So here, to standardize it, we go 25 minus 15 divided by 4, giving us a value of 2.5. So we look up 2.5 in the table for the standard normal distribution. There we find 0.9938. If we subtract this from 1, we get a probability of 0.62%. So the chance that someone will spend more than 25 euros is 0.62%. So much for part A. Part B then is relatively easy, because we just have to multiply the probability we calculated in A with the 10,000 visitors of the food court. So giving us here, there's in total 62 persons who will spend more than 25 euros in the food court. This already was part B. We switch to part C, where we were asked to calculate the probability that someone will spend between 10 and 15 euros. As we know that, the mean is 15, so 10 and 20 are equally distant from the mean. So we can simplify this as just calculating the probability between 10 and 15 and taking this twice, because the normal distribution is symmetrical. However, this again is a bit problematic. So what we do instead is use one of the simplifications where we have 1 minus 2 times and then probability of x being lesser than the lower bound. That's something which we can do when we have an interval, upper and lower bound, and they are both equally distant from the mean. So here we can use this, meaning we only have to calculate one probability. Okay, still we have the same mean, we have the same variance and thus same standard deviation, so we only need to standardize the 10 and look the value up in the table. So here if we standardize this, we have 1 minus 2 times phi 10 minus 15 by 4, giving us here a value of minus 1.25, which I would have to look up in the table. Again, I cannot find negative values in my table, so instead I transform this into 1 minus phi of 1.25. And the 1.25 I can look up in the table, finding there a value of 0.8944. Then I only have to calculate the expression I have here. Putting this into calculator gives me a value of 78.88%. So the chance that someone spends between 10 and 20 euros is 78.88%. And well, this then concludes the third and final part of this exercise, and I hope you enjoyed listening to it. If you're looking for more exercises, feel free to visit the rest of the exercise set or have a look at the corresponding playlist. I say goodbye and see you next time.